Question 17. Now, I believe by doing part A, I might enable you to finish this question, so you're welcome to stop the video at any point and carry on with the question yourself. Otherwise, I'll try and make this reasonably quick, so stop, pause, rewind as you see fit. So question 17 is about a cylinder inscribed inside a cone. We're going to have to use a little bit of similar triangles to help us solve this one. So first of all, the question A is asking us to show that the volume is equal to 10 pi r squared 6 minus r over 3. So I'm going to start by writing down my standard volume formula of a cylinder. Volume equals pi r squared h. Now, what I need here is I've got the first relationship. I am trying to maximize the volume, it states here in part C. So of course I'm looking for some way of eliminating the r or the h. And because the h is a simpler term, I'm going to try and eliminate the h. So I need to find some other relationship. So what I'm going to do is I'm going to take this diagram here, I'm going to draw it in a slightly different way. Imagine if instead I looked at the triangle that's formed inside this cone. Now this triangle has a height of 20 and a base of 6. But inside that triangle is another triangle that's formed by the cylinder. So if I just draw my little 2D view of that half cylinder there, and you'll notice here that the cylinder has a radius of r and a height of h, which means of course that this length here is 6 minus r. So, in other words, I'm dealing with a triangle that looks like this. My big triangle is 20 and 6, and in pink, my little triangle here is h, and apologies about that little bent line I've got going on there, and 6 minus r. And so therefore, in blue, I have a similar triangle ratio or relationship, and that is that h over 6 minus r is equal to 20 over 6. There's a direct ratio in my similar triangles. This could probably be built up through a trigonometry based argument as well if you let theta equal this angle in here. So I've got that relationship there, which leads to h equals 20 6 minus r over 6, and that leads to h equals 10 6 minus r over 3. So I'm going to take this information here and I'm going to pop it right there, and it will give me this outcome. The volume therefore equals pi r squared times 10 6 minus r over 3. And when written out, that is 10 pi r squared 6 minus r over 3. So that's pretty exciting. That's part A. You may choose to stop the video now if you'd like. Going on to part B, I'll just check the question. Hence find the values of r and h for the cylinder which has a maximum volume. So I need to maximize the volume first of all. So let me just expand this out first. And I get 10 pi r squared times 6. I might actually just, oh actually no, I'll change that to 20 pi r squared because the 6 will cancel with that 3 quite nicely. And then minus 10 pi r cubed over 3, which in itself is going to be quite nice because when I do dv dr here, I'll be left with 40 pi r minus, and the cube would cancel out with the 3, giving me 10 pi r squared. Now, to maximize, I need to let dv dr equals 0, which gives me 40 pi r minus 10 pi r squared equals 0. And now solving this, first of all I might just cancel the pi's, can't divide by pi's, divide by 10, leaving me 4r minus r squared equals 0. R times 4 minus r equals 0, and r equals 0 or r equals 4. Now I suspect we're dealing with a cubic initially, as we can see here, so there is going to be one maximum, one minimum, and r equals 0, having a radius of 0 is going to give you quite a small volume, hence I expect that would be the minimum and r equals 4 would be the maximum. That would be a reasonable solution to get, but we should always check and just show that we understand we need to verify everything that we do. So d squared v dr squared is equal to 40 pi minus 20 pi r, and then at r equals 0, this is equal to 40 pi, which is positive, which is a minimum, and at r equals 4, the squared v dr squared is equal to 40 pi minus 80 pi, which equals negative 40 pi, which is negative, and that implies a maximum, obviously. So we do have r equals 4 is a maximum, and then of course to finish this question we need to calculate the value of h at r equals 4. At r equals 4, h is equal to 10 6 minus r over 3, which is obviously 10 times 2 over 3, which is 20 over 3 is an exact value, and therefore the volume, so this is part C now, is equal to pi r squared h, which is equal to pi times 4 squared times 20 over 3, and that of course is equal to 16 times 20, so 320 pi over 3 and centimeters cubed. And we've done all our checking again. Go back, put it into context, whatever you need to do from here, but the question is finished.